This is good. Tell the truth, you never wanted me. Tell me. Dreams are jealous all the time.
Thanks again for joining us today. I'm now going to turn it over to Encapsulator Technology Specialist, Dan Miller.
Good day, everyone. Welcome. Thank you for joining us today. My name is Dan Miller. I'm an encapsulator technology specialist located in Nebraska, USA. I'm a retired fire chief with 40 plus years of fire experience in rural, mid-size, and metropolitan class cities, hazardous materials, and many years of fire service training experience in structural firefighting, industrial firefighting, etc. Always been a fan of new technology. I've been a technology integrator for decades in the fire service, and this technology is no different. It's a game changer that we're going to talk about today, and I'm going to maybe introduce some topics here for a couple of minutes to give a few people more time to join us today. But one thing I would like you to do with us today is to tell us why you're here, whether it's because you're looking at a foam replacement technology, you're looking at firefighter health and safety, you're looking at being more effective at saving lives, saving property, or protecting the environment. Let us know in chat why you showed up today, why you came. We'd sure like to know that. It helps us aim our future webinars at those particular issues that you're most interested in. So we're here to share today, share a lot of information with you on how firefighters can more effectively save lives, gain effectiveness, and use a water additive technology to lower the impact on the environment while saving lives faster, better, more effectively, making your firefighters more effective in everything that they do, so that you can also impact their safety in operations. So we are the manufacturer of a product. Hazard Control Technologies manufactures a product called F500. And that technology, got ahead of myself there a little bit. That technology is a water additive technology, falls under NFPA 18A. We have a worldwide distribution network. We're located in the USA. Our headquarters facilities in Georgia, USA. But we do have a worldwide distribution network. So no matter where you're calling in from today, rest assured that we have the ability to not only supply you with products, but through our distributors, also the training that you need to use our products most effectively. So all of our encapsulator technology specialists, including myself and our distributors, have fire service background and can help you with your training needs as far as applications of these technologies go, especially in light of the new threats that we're dealing with in the world. There are a lot of new threats out there, but there are a lot of existing threats as well that this technology can just be help us be much more effective at dealing with those problems. So as we go along today, if you can please keep your microphone muted other than to ask questions during the live Q&A segments, which will open that up towards the end of the presentation here to give you a chance to ask questions. In the meantime, however, if you would like to ask questions, and like myself, if I don't ask them right away, I forget about them, then please type those questions into the chat. And then when we get to the question and answer session, we will definitely address those questions one at a time. And then if you'd like a copy of today's presentation, make sure you're registered with your accurate email address. So Hazard Control Technologies, again, we're located in Fayetteville, Georgia. We've been in business since 1997, making F500, as well as some other products. We have engineers on staff and engineering support, as well as trainers, instructors, specialists in the areas of technology that our customers need, including the fire service, but also industry as well, including the sprinkler industry and specialty industries like the coal industry, the petrochemical industry, for example. We're an ISO 9001 company, which means that our products meet specific specifications and manufacturing process consistency and quality throughout. So our products have been the same for 25 years, haven't changed, and they won't change tomorrow either. So our formulations have been the same throughout. Every time you purchase product from us, it will meet the same exacting specifications. So we're specialists in the control of modern day combustible hazards. However, as you're going to see as we talk about this technology, combustion doesn't change. Some of the characteristics and effects of the things that are burning change the environment that we're going into, but combustion remains the same. The technology behind stopping combustion remains the same, but F500 and hazard control technologies approaches that combustion puzzle with a water additive technology that is innovative because it works on a chemical molecular basis rather than a mechanical basis. So if you'll join us today, we're going to take a look at some of that technology and how it impacts the fire service, the benefits that it brings to firefighters, as well as the people that we're trying to save. And that's what we're all here for, is to save lives. And we believe this technology can help you do that more effectively in your job. So thank you for joining us. So F500 encapsulator agent is our premier agent that we make. We also distribute equipment, manufacturing of equipment that helps deliver F500 better. But really all you need as a fire service participant is a regular hand line and nozzle to deliver F500. You don't need anything special, and it's applicable to all classes of fire, including energized environments. So there are no known contraindications in firefighting to our agent, and it's a very broad spectrum agent with many, many benefits to everyday firefighting challenges that fire departments and fire chiefs face in your communities back home. I know as a fire chief, you face many different hazards and challenges, from crashes that occur in your jurisdiction, industrial facilities, transportation related incidents, pipelines, natural vegetation fires, ag-related fires, um, railroad-related fires, structural fires, and now we're looking at things like lithium-ion battery fires, and also just that energized environment. But also we're looking at infrastructure like energy production, transformers, etc. And you're going to see as we talk more about F500 and what its capabilities are and what its pluses and benefits are, really how it can benefit you, saving time on scene, reducing risk, reducing runoff, and truly saving lives more effectively. So the first thing we're going to talk about today are structure fires. What are the various risks associated with some of those contemporary structure fires, and how that's impacted not only our response and firefighter safety, but also who it affects most, and that's the people who may be trapped inside, including their pets. And most people include pets as part of their family. And I know firefighters, we have to manage the risk that we're dealing with. But I know firefighters will definitely take calculated risks to save pets as well. So we're trying to save lives throughout and control the risks and improve the outcomes with F500 as a water additive. So we're going to talk about how that works in the structural fire environment. So some structural hazards that we're facing nowadays that are on the increase and are game changers in how we respond and the tactics that we use and have to use to be more successful include synthetic materials, and everything that we can buy at the local whether it's a big box store, whether they're dealing in hardware, wood products, home goods, doesn't matter. It's all synthetic products. So those synthetic materials, they burn differently than the natural materials that our ancestors had in their homes. So we're going to take a little bit of a look at that and how that is a game changer as far as the speed of development of fires and the progress to what we call a ventilation limited fire that actually compromises life and firefighter health and safety. Lightweight construction, we have less time to building collapse than before. And not only that, but faster fire spread once it gets out of the immediate structural envelope of a single room and gets into the structure, it can spread faster due to lightweight construction techniques. Rapid fire spread throughout the interior of the structure, not only due to the lightweight construction and some of the construction techniques that could be open air construction, fewer smaller rooms, more larger rooms that are open from room to room, but also the predominance of the synthetic materials and how in a ventilation limited fire, that dark cloud of synthetic laden smoke can carry airborne fuels from one room to the next, and that aids in fire growth from one room to the next as that convective cloud reaches its ignition temperature, lights off, rolls over, flashes over from room to room to room in a very short period of time and consumes the interior of the structure, threatens lives, causes acute respiratory distress in humans and animals, and then makes it much more difficult for firefighters to find those victims as well once firefighters do arrive. And when we do arrive, we're arriving to a flashover potential that's almost always either already occurred or is on the verge of occurring. We don't have the time window that we used to have. So this next video is going to show you an example, and many of you that study fire science and structural fire behavior have seen some of these videos, but this video shows and illustrates how in legacy fires things developed much more slowly than they do now in the fire environment that is not only loaded with synthetic materials like carpets and so forth, but packed with synthetic furnishings, synthetic upholstery, and lots of synthetic things that we get at the store. So the picture on the left, or the video on the left and the video on the right, present two different scenarios, very similar furnishings. The one on the left is legacy furnishings, mostly natural products, cotton coverings, wool coverings, horsehair rug, natural stuffing in the couches and so forth, real wood products. Curtains probably were not synthetic. The one on the right, however, is modern day, mostly synthetic materials that make up the coverings, the couch cushions, the curtains, the furnishings, etc. Even the wood isn't real anymore. It's some kind of medium density foam, or maybe a particle board filled with glues and then surfaced with some kind of a laminate that's actually synthetic. So you'll see the one on the right is growing much more quickly than the one on the left. We're only just a little over 4 minutes and it's already rolling over. And any moment now we're going to go to full flashover. Whereas the one on the left, it's not even life-threatening yet. And that flashover occurred in 4 minutes and 50 seconds on the right-hand side, which is a really short period of time. You're not even arriving yet as a fire department, even if the smoke detectors went off or some type of a detection system detected it. You are not arriving at that fire yet in most cases as a fire department. You've got a few minutes until arrival yet. So you're already behind the 8 ball when it comes to flashover and saving lives, making a difference. The one on the left is finally, after now the clock has been advanced to 30 minutes, it's finally getting to the point where it's life-threatening and banking down, and will proceed to flash over in a matter of minutes. And in all of these cases, these studies were done by UL Fire Safety Research Institute, and NFPA did some as well. In all of those cases, in the legacy type homes furnished with legacy material, built with legacy materials, the flashover was over 20 minutes out, whereas the flashover in the modern home was proceeding within around that 5-minute mark. So we've got a much smaller window of time to make an impact on life safety of the occupants, which is the primary reason we exist as a fire service. So also the content in structures and our means of transportation, the power tools that we use, they're all powered by lithium-ion batteries now. So in the larger cities, they're facing more and less an epidemic of situations involving lithium-ion batteries, including these personal mobility devices, the scooters, the hoverboards, those kinds of things, on up to wheelchairs and so forth. But we all know we've got those cordless power tools at home. I know of several structures that have burnt down in my community due to charging issues with lithium-ion batteries and cordless tools. There are rogue bike and battery repair shops in a lot of the bigger cities because the demand is there. The demand for these products and keeping these products running is there. So they set up rogue shops. And in the picture there, you're going to see a rogue battery or bike repair shop that above those shops in a lot of the larger cities is multi-residential family housing. So when a fire occurs in one of these shops at the base of one of these multi-residential structures, you've got a situation where there are many lives threatened, and the fires are difficult to put out. They're intense, and it's again, you're arriving late to a situation that's fully developed, and they're a real challenge to life safety. Many people have been killed over the last few years by these situations in the different, especially larger cities. But it's coming to the smaller cities as well. And what you're going to see in this next video is how the predominance of the gain in population, population density, has really made an impact on that fire situation, and the predominance of fires and the life threat. Hang on one second here. There's something going on my screen I want to get ahead of before it turns into a problem. There we go. All right, here comes the video.
Scene.
So in this part of the video, you're going to hear Chief Brian Lee, Paintertown Volunteer Fire Department in Pennsylvania, talk about their application of F500 on a battery electric vehicle fire. They showed up to this fire as a mutual aid department to assist their neighboring department, and it's going to talk about the chief's going to talk about their experience with F500 at that fire.
Assisting the Level Green Fire Department, they dumped over 500 gallons of water on it, and the car kept flaring up. We pulled our trash line off with the F500, and we used 1.5 jugs of the F500 and about 450 gallons of water, and the fire was out. Cooled down enough, the tow truck driver was happy. No flare-ups again once the F500 was in use.
So it really comes down to is yes, there is occasionally the opportunity for an EV to burn or lithium-ion battery to burn without nearby exposures to the public and life safety issues, also to firefighters, and occasionally you can let them burn. But when lives are on the line, whether it's a crash situation or in the case of the Rogue Bike Shop inside of an apartment building, or mobility device, or even a cordless tool charging inside of someone's private living space, that time is of the essence, and the right technology to put those kind of fires out quickly is absolutely critical. So we look at, when we're sizing up the overall risk, we're looking at those modern combustibles, the synthetic fibers, glues, adhesives, lithium-ion batteries, lightweight construction, I-joist flooring, oriented or OSB strand board, that chipboard that you see that most buildings are constructed out of nowadays, truss roofing, especially in multifamily dwellings with vinyl siding, for example. A fire on the outside of a structure with vinyl siding can take the roof off of the building in no time at all, especially with a little bit of wind. The toxic atmospheres presented by all of those synthetic materials, when it comes to things like lithium-ion batteries, the toxic atmosphere is even worse because it's extremely debilitating and life-threatening with a very low amount. And then the fire ground results from all of those different risks and materials is a quicker flashover, early and rapid fire spread, frequent early collapse without a lot of warning, and an environment that's immediately dangerous to the life and health of not only the occupants, but firefighters as well. And it makes it more challenging in a structure fire to go ahead and search and find those victims, locate them, and get them out safely. So we're going to talk about mitigating the risk with F500, shortening your time on scene, seeing faster results with this water additive technology that we're talking about. And because of those faster results, you're using less water, you have less water, less runoff, less impact on the environment, and less impact on your firefighters as well. This next video is going to show you the formation of what we call spherical micelles inside of the water droplet, and how the water droplet is altered by the presence of F500, and how that on a molecular level makes an impact and a difference on the fire.
Encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet, with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So as you look at this water droplet that we have here on the screen, the blue part is the outside or outer level or layer of a water droplet, with F500 having been mixed into the water solution. So the outside of the modified water droplet with F500 includes a skin of the F500 molecules with the polar head pointing inward towards the water surface, and then the nonpolar tail of that same molecule pointing outward. And that creates a unique feature for gathering heat, carbons and hydrocarbons, as this droplet's flying through the air, impacting liquid surfaces, impacting porous solid surfaces, etc. And it also helps it absorb heat quickly into that outer skin of each water droplet. And then on the inside of each water droplet, because those F500 molecules are on the inside of the water droplet as well, but those nonpolar tails fear water and hate water, the molecule flips or inverts the other way. So we get these little golf ball looking things on the inside, and those are the spherical micelles. The spherical micelles are simply the collected F500 molecules with the tails pointing in and the heads pointing out towards the water. Now, on the inside of each spherical micelle are the encapsulated carbons and hydrocarbons out of that combustible atmosphere. As they were flying towards that fire, going through that combustible atmosphere and all the heat, they were absorbing those carbons and hydrocarbons out of that atmosphere, taking those on as passengers, as weight, and penetrating that fire very well. And again, the inside of this water droplet is absolutely packed with those spherical micelles. So you might see 50 or 100 on your screen, but actually there's millions and millions of them in each tiny water droplet. The water droplet itself, because F500 is a surfactant, is allowed to be much smaller than a plain water droplet, because it simply doesn't have the surface tension any longer of a plain water droplet. And then it has a much higher molecular weight, at least 50 times that of a regular plain water droplet. So the impact on the fuel surface and through a thermal column, for example, it just performs much better than a plain droplet of water. Because of the size, the makeup of the water droplet, they absorb heat much more uniformly than a droplet of plain water as well. And that uniform heat absorption really has a greater caloric cooling effect than water, from anywhere from 6 to 10 times better. In some materials even better than that. So, but at the very minimum, 6 times better than plain water.
Encapsulate.
So we look at the summary of the features and benefits of the F500 waterborne molecule. Got hydrocarbon and carbon liquid encapsulation. So we're encapsulating carbon and hydrocarbons, and that's truly what's combusting. When those carbons and hydrocarbons, the volatile organic compounds, get oxidized, they create combustion, they create heat, that exothermic reaction that results in flames. Flammable vapor mitigation. So when we have things like gasoline or diesel fuel on the ground or in a tank, and they're volatile, they're vaporizing, we're able to, this F500 molecule is able to gather up those vapors and encapsulate them and inert them or neutralize them. And then when it actually strikes the liquid surface with a little bit of force, it does the same thing to the liquid. And by volume, we can actually encapsulate either the entire surface of the liquid, which puts the fire out, or in some cases, if we're trying to mitigate a spill, the entire volume of the spill can be mitigated, neutralized, and encapsulated, much to the benefit of putting out the fire, preventing fire from occurring, and also as a benefit to the environment. Rapid heat reduction, we talked about the ability to absorb heat very rapidly. We're going to show you in a little bit how the interior fire, for example, can go from 1200 degrees Fahrenheit down to 127 degrees Fahrenheit in a matter of seconds, even at 1% F500 in water. So you have that rapid caloric absorption. Long-term stable burn back resistance. What's that mean? On a liquid pool, that means you're not suffering that burn back like you would with foam potentially. But when it comes to a structural fire, an application in the structural fire environment, from that first application of F500 with the initial fire attack hand line, you're eliminating the possibility of flashover right there, right then, right that fast, both by the temperature reduction, the coating with the F500, the wetting of the materials, the absorption and or encapsulation, the interruption of that free radical energy. It takes away the potential for flashover right away. Who does that benefit? That benefits everybody. That benefits your firefighters as they're advancing towards the fire and finding the seat of that fire. It benefits the victims who are unwittingly trapped inside of that fire, and it lowers the temperature for them, as well as it reduces the toxicity in the air at the same time. So, and then kind of the last thing that it does, and I wouldn't say it's last, it's just the last thing on the list, it improves visibility greatly. Initially, there's some water vapor that comes off of it, but as soon as that clears even a little bit, the visibility clears right up and enables your search. So these next few videos, we're going to talk about spill fires first, and how F500 can work on a spill fire to your advantage. And then we'll look at some structural firefighting as well. So we've encapsulated the center of this spill. We're showing you how the encapsulation takes away the ability of the product to vaporize on a molecular level. It's no longer a fuel. So we've lit the fuel that has not been treated. Now what has been treated is no longer fuel. And you'll see how it resists heat. It really resists that burn back. You're not going in there, it's not a blanket. It's actually mixing with the liquid fuel. So it makes a huge difference in how you apply it and the speed of the effectiveness. We're not gently rolling on a blanket of foam, that's very technique specific for potentially minutes to hours. we're putting it out in seconds to minutes. And we're having that rapid impact that saves lives in those situations rather than just saving property, time, and fuel. We're actually able to save lives with F500. Well, it makes a big, big difference on those spill fires. And the thing I like to relate to that is when you're on a crash scene and you've got fuel on the ground and there's an extrication or a rescue to be made, having that confidence that the stuff on the ground is treated and is no longer a threat is a big benefit. If it's already on fire when you arrive, you can put it out very, very quickly and make a difference in a situation where life safety is on the line. Whereas with foam, you really don't have that capability. It's a slow application with a slow result. Rapid heat reduction. We've got a couple burns here that were conducted in Maumee, Ohio. The first one with a 0.5% F500.
All right, so let's open it up and check this out.
This is a transitional attack from the outside of a burn room. Our next one will be an interior attack. Measuring the temperature at the ceiling, also looking at the fire, but measuring the temperature at the ceiling. Making sure we get a good hot burn going.
1,200 at the base of the fire, 1,000 at the ceiling.
Got 1,000 at the ceiling, almost at that temperature where carbon monoxide would light off. Now they're going to make an exterior application, narrow stream, a few seconds with that 500 at half. You're going to notice some water vapor come out. Momentarily here, they're going to recheck the temperature at the ceiling.
400 at the base, 250 at the ceiling.
250 at the ceiling. Approaching survivability mode. You also got a rapid increase in visibility to make a rescue if there's one that needs to be made. So the next one is an interior fire attack in 0.5%. Interior fire attack.
You got good thermal layering inside the window.
Same indirect kind of attack on the fire. I'm going to look at, again,
What's your
ceiling
temperature?
temperatures.
932.
The ceiling temperatures are most closely related to the ability for the fire to flash over and grow throughout the structure. That's leaving space fire going in the trench burn anyway.
You want to hit it, Ron?
See that lower stuff doesn't look like it's burning. No. That's stuff that from this morning.
Go down on that lower stuff.
300.
That's probably it coming from it strong.
Yeah.
That lower stuff's not burning.
About 230 at the bottom and 930 at the top.
That's it. I got 975 and I was inside.
932 at the top and about 300 at the bottom.
You're not gonna do that bottom thing burn.
So that fire has become ventilation limited now. The application is up 500.
470.
Water vapor coming off.
113.
Now we've got 113 at the ceiling. So definitely
How hot was that? What's your temperature in the hallway, guys? Hot. Hot. What's the temperature in the hallway right now?
77.
77, that's it?
Yep.
that's just water vapor that you're seeing there.
120
here in a minute.
120 in the, you got 120 in there in the hallway? I'm getting 95 at the ceiling. $195 at the ceiling.
You see that shiny object through the steam there, and that's not really steam, it's just water vapor. Steam you can't actually see. That's a helmet reflector. So our visibility is already returning in a matter of a few seconds after application, probably less than 30 seconds. That visibility is coming right back. We've encapsulated a lot of those combustible volatile organic compounds and polycyclic aromatic hydrocarbons out of that atmosphere that would otherwise obscure visibility. Those are gone. All that's left is the water vapor. As soon as that kind of clears out, your visibility comes back, and it's a lot cooler, more survivable environment for victims that could still be surviving, as well as firefighters that are trying to find them.
Went from about 930 degrees to about
So again, from 1,000 degrees to standing in it.
120 in about 20 seconds.
Wow.
Of that.
I'm sorry, go ahead.
Went from about 930 degrees to about 120 in about 20 seconds.
That's impressive. That's impressive.
And that steam hit me. It was no hotter than a shower.
No, that's not steam then. That wasn't steam. That's not steam. That was the vapor we were talking about.
Again, that isn't steam. If you can see it, it's not steam. It's water vapor, and it's very comfortable. It's like a warm shower. It really, really is. Very survivable. Next video, we're looking at the interruption of free radicals. So this is a little bit of a more difficult concept to explain to firefighters when we go out and talk about this technology, is the interruption of free radicals. So any combustion on Earth's surface is incomplete. So when you have incomplete combustion, and especially when you have more synthetics involved, you get more free radicals that come off. Free radicals are atoms with an imbalance in electrons. What are they seeking? They're seeking balance. So they join up with other imbalanced electrons to form all kinds of new compounds. They're volatile, they're organic compounds, and they're also what we call polycyclic aromatic hydrocarbons. But whether they're volatile or aromatic, that means they're airborne and they're obscuring vision. They're flammable. They're going to cause the fire to grow when they light off. And they're also extremely, extremely toxic and cause acute respiratory distress along with the heat and any victims that are in that environment. And we can eliminate that very, very quickly with F500. And that's truly what makes F500 a life-saving water additive. So what I want you to watch in this video is, as this is applied, and we're checking our stream first to make sure there's F500. That's the milky white stuff you're going to see in the stream. We're not creating foam. We're doing the opposite of that. Whereas foam is the whipped cream on your coffee, F500 is the creamer in your coffee. So as this fire is struck with the fire stream of F500, I really, really want you to pay attention to that dark column of smoke and how rapidly it disappears. It'll just be gone. It's pretty amazing. Again, checking the stream on the ground. I recommend, firefighters, make sure you got F500 in the stream for your initial attack line. That way you're going to get F500 results. Look there's no smoke. It's gone. And the tires are rapidly cooled. That's a rapid heat absorption effect. That's a 1% application. Ours are getting off as tan water vapors right now. Going to cool the other side a little bit, but even watch these vapors disappear as he gives it a second hit. So those vapors disappear as well very, very quickly. So that free radical interruption theoretically comes from the high molecular weight of the product and the inability of it to interrupt what we call the coalescence or coming together of those free radicals into new compounds. So that smoke, number one, we're absorbing the stuff that's already formed, but we're interrupting the formation of new smoke compounds, which is really where it benefits firefighters. So conclusion from all of these is that there are many benefits and impacts to using F500 when it comes to the people we're trying to help, but only when it comes out with the first drop of water on that initial attack line. If it's still sitting on the truck in a jug or in a foam system, it's not helping anybody. So to save lives and make firefighters more effective, we have to follow this mantra in our daily operations, and that is, as water flows, so does F500. Then we're getting the benefits. We're going to be off scene a lot sooner. Our victims are going to have better outcomes. We're going to have better outcomes. We're going to have less risk and exposure just due to our less time on scene, if nothing else. This next segment, we're going to talk about what we call the Laval report. So in 2020, 54-year-old Langis Villanueva perished from cancer. And the Laval Fire Department, which is a community of about 400,000 people, so not a small town, just north of Montreal, they conducted a study. They knew of F500 and they had begun to use it, but they wanted to conduct a study to see if it would impact firefighter safety and health if they used it for every fire attack. So they conducted a series of burns on an acquired structure. They conducted 4 interior structural burns. The first 2 burns involved one burn with plain water. Burn 2 was with F500. And then they did another room as well with the same thing, but we're going to talk about the results here a little bit. So initially, from that first set of interior attacks, one with plain water, one with F500, these are the feelings, the post-fire observations of the interior handline crew and the officer in charge. So what they found, what their quotes were, was that with the F500, we were able to stand immediately after extinguishment without feeling heat. Not always great, you know, personal protective equipment only goes so far. So we really try to tamp that down in training, but with F500, that's truly occurring. That heat is gone. With F500, increased visibility increased significantly, reducing the amount of smoke present. With F500, we acted quickly to extinguish the secondary fire by simple deflection of the primary attack. They go on to say, comparing fires 1 and 2, there is no doubt from an external point of view that fire 2 was brought under control more quickly with F500 encapsulator agent. Following the extinguishment of fire number 2, the presence of residual smoke was much less after using F500 encapsulator agent. So it really, if you look at the impacts of those statements alone, it impacts your operations from initial attack through the investigative phase of the fire, your entire operational time on scene. So fires 3 and 4, similar outcomes observed by the interior firefighters, the officer in charge. These are their observations. So after the initial application of F500, flames on the floor disappeared in a fraction of a second. The decrease in smoke generation inside was striking. In addition to the most important factor, the second fire was much more violent. The fire with F500 ended up being more violent. There was considerable less smoke at the source after the fire. There was considerably less smoke at the source of the fire after applying F500. Comparing fires 3 and 4, no doubt from an external point of view, fire 4 was brought under control more quickly with F500. And following the extinguishment of fire 4, the presence of residual smoke was much less after using the F500. So let's talk about some of the actual numbers rather than just observations. So these are the actual results. So you'll see at the top, we've got what we call the PAH toxins. PAH is polycyclic aromatic hydrocarbons. Those are the things that kill firefighters. If we didn't wear SCBA, it'd be killing us through our respiratory tract. But since we're pretty good at wearing SCBA now, or we should be, this can still be absorbed through the skin, and a lot of it is, especially warm skin. So as you'll see, fire 1 and fire 2, one was water, one was F500. And then you're going to see the polycyclic aromatic hydrocarbons, fire 1 versus 2, same with 3 versus 4. And these are measured in nanograms per cubic meter. And these measurements were taken on brand new protective hoods with new helmet liners for every attack. And they were gathered very carefully, bagged up, taken back to Ottawa University for testing. So these are university tests. Along the left side, you'll see those chemical names in red. Those are all the PAH toxins that were present in the smoke, or that were measured for by the instrumentation. And you're going to see in almost all cases, you either have a lower reading or an undetectable reading after the presence of F500. And then let me show you a little bit different look at the same information. If you compare it on a graph, we've got fire 1 on the top, or excuse me, room 1 on the top, room 2 on the bottom. The blue bars is plain water. The orange bars are the polycyclic aromatic hydrocarbon accumulation on the turnout clothing sampled with F500. So you've got a much lower instance of the PAH buildup on turnout gear that ends up getting on your skin, not only immediately at the fire, but after the fire when you're cleaning fire hose, taking off your turnout gear, disassembling your turnout gear, getting it ready for laundering. That stuff is being reabsorbed into your skin, re-aerosolized into your nasal tract and into your respiratory tract, but none of it's good for you. The nice thing about applying F500 is that we're treating that both that accumulated hazard on the turnout gear as well as the atmospheric hazard immediately, and reducing the presence of those PAHs and VOCs in the atmosphere. But we're really cutting down on that exposure to cancer causing products in 2 ways. Number one is that airborne problem, but we're also cutting down our time on scene, which is really, really important and directly related to exposure. So their committee of 30 firefighters agreed that the committee is confident the encapsulating agent reduces firefighters' exposure to carcinogenic contaminants. Furthermore, it's also effective for Class B, C, and D fires, while water should not be used on plain water should not be used on fires of those categories. For those reasons, we are moving forward with the use of an encapsulating agent to prevent cancer in Laval firefighters. And because of that, they use F500 in every fire stream for every fire for initial fire attack. Again, to save lives and make firefighters more safe and effective, which is a major measure of safety, is we have to follow this mantra in our daily operations. As water flows, so does F500. This video here shows a fire attack in Omaha, Nebraska. They had taken on F500 tentatively for a pilot study and had a 1% tank mix in this particular fire department pumper for this fire attack. We've got a fire with heavy involvement on the alpha side of a 2-story single family dwelling structure. And he's going to get water at 1 minute after arrival. And then he starts applying water. 44 seconds later, that fire is under control.
I got water.
Understood. Truck 63 is splitting. You search new van. Truck 63.
We got water? What's up?
Come in on site C here.
Back Yes, sir.
Got a little mop up to do with this nozzle yet. This house ended up being a vacant house. Somebody lit something on the front porch on fire involving the front or alpha side of this house. Got a little bit of extra application up here in the eaves and under the front porch, but they did proceed directly to a primary search of the structure. Found no fire extension on the inside of the structure whatsoever. So really, it's a force multiplier when it comes to your firefighting forces, especially if you're challenged by manpower limitations and distance from the fire station and things like that. F500 is a real game changer by adding power to each fire stream to make a difference. You do a transitional attack with F500. In many cases, you go in and the fire's out, and you can see great. They were actually picking up and leaving this fire after 15 minutes of on-scene time.
Gentlemen, mask up.
Yeah. I'm having them take that in. Then we'll just...
Well, that's pretty impressive as well. When you can be on scene for 15 minutes on a well-involved house fire, that really impacts the risk of your firefighters. It really reduces that risk and puts it in check. And if you look at that over a career span, it's going to be a big reduction in accumulation of carcinogens. So in this interior, this is an interior burn simulator. You can see it's gas fed. You can see the burner at the ceiling back there. That's to create an artificial rollover. It's lined with either the ceramic panels or steel panels, which usually create a lot of steam when plain water hits them. One thing you're going to notice with this is when the F500 hits this gas-fed fire, and that's just a class B, what we call a three-dimensional gas-fed fire, not only going to knock it back very quickly, but those superheated panels won't put off any steam. Visibility is maintained throughout.
One of the things to watch for here, Brian, is the lack of steam generation. These walls are hot. We preheated this room a little bit. These walls are hot.
There's your rollover simulator. Walls are super hot right now in direct flame contact.
Better hit it or it's going to go out.
See how visibility is really maintained throughout. It didn't turn to steam, it just cooled. Got some water vapor, but even very little bit of that. And that's a natural gas fed fire. All right. Now in this fire, we're looking not only at the effects on the fire, the smoke, the visibility that's maintained, but we're measuring carbon monoxide levels. Carbon monoxide is a major killer of occupants, hazardous to firefighters, hazardous to pets, and fires typically put off hundreds, if not thousands, of parts per million of carbon monoxide and fill a room very, very quickly. We're going to take a reading on the carbon monoxide here in a minute. you see that visibility is not too shabby. You know, cameras don't pick up visibility that great in a fire situation, but visibility pretty well intact. And carbon monoxide, 2.5 minutes after extinguishment, only 13 parts per million. That's less than the permissible exposure level for an 8-hour exposure.
CO13.
That's a big difference and a big deal. So we talked mostly about structural fires in today's presentation. Also, we have a lot of information on Class B firefighting. We have a lot of information on Class C energized fire environment firefighting. We have a lot of information, over 15 years of research and development on lithium-ion battery fires, more than any other fire suppression agent manufacturer in the world. And we've had a great success with that, and we'd love to share that with you as well. But from a structural firefighting perspective, and the things that we do day in and day out as firefighters, adding a little bit of F500 to your water is really cost effective, because water delivery is definitely not free. If you look at how much you paid for your last water tender, how much you paid for your last pumper, how much it costs for personnel time on the scene, it's hundreds of thousands, if not millions of dollars a year. And F500 can cut down on that water use, your number of trips hauling water if you're in a rural environment, your time on scene in any environment, your pump time, et cetera, et cetera. The effectiveness boost of F500 is pretty amazing. And when it comes to saving lives, it's really a life-saving water additive, which you look at why you bought your last defibrillator, why you bought the thermal imaging camera, why you bought a lot of the equipment you have, you justified it for saving lives. This truly does save lives. And all you have to do is use it with the first drop of water. For delivery, water can, fire extinguishers, those pressurized fire extinguishers that you fill yourself, you can put it in there at 3% solution, increases your knockdown capabilities of for those of you that run with a can man. You can batch mix it right in your booster tanks on your rigs. It lasts for years that way without any detrimental effects or degradation. You can use inline eductors, a little bit slower setup. I like to see departments go a little bit a different way, but we work with departments to help develop that capability. You can use your onboard electronic proportioning systems. We're compatible with most, if not all of them, and have certification in several of them. Again, we can help you with that. We do have some other options like portable water-driven proportioners and proportioning trailers. And the benefit of those, and I'll show you a picture when we're done here, but benefit of those is you don't have to worry about how much hose is beyond your proportioner. With an inline eductor, you do, and they're kind of finicky to work. A water-driven proportioner is not finicky, and you can even supply a standpipe through the fire department connection, for example, or a sprinkler system through the fire department connection and put F500 into the sprinklers from the street. You know, very beneficial to keeping your firefighters out of harm's way in the day and time when there could be multiple vehicle involvement in that parking structure or EV involvement, for example. Got a lot of ways to deliver it. The nice thing is you don't have to aspirate it. You don't have to use special equipment. You don't have to use special techniques to apply it. Just apply it with a fog nozzle and apply it aggressively and see the results. It'll be very surprising to you. It's a UL listed A and B agent. Water additive conforms to NFPA 18A, a relatively new standard, and it conforms specifically to Section 7.7. Section 7.7 really is a delineator between those things that claim to be encapsulator agents and those that are not, because there's a lot of copycat manufacturers out there now that are claiming, oh, we have an encapsulator agent. they're not, and they won't even come close to conforming to 7.7, which is the defining criteria for an encapsulator agent. It's on the EPA NCP product schedule as a surface washing agent. So when it comes to washing down fuel and oil spills and things like that, those oil spills are mitigated very quickly and biodegraded very quickly when they're encapsulated with F500, because those carbons and hydrocarbons are captured in the spherical micelles, and when they're washed into the soil, the microbes in the soil are hundreds of thousands of times larger than a spherical micelle, and they eat them up, and it's healthy for them. It's good. MSHA, Mine Safety Health Administration, controls all the mine safety in the U.S. and in some other locations as well. It's a listed agent with them, the firefighting agent, and then more recently, as of 2023, it's on the FAA AC-150 circular, listed as a complementary or other firefighting agent. So we have a lot of interest from aviation authorities, airport fire departments, etc., especially in the light of, they know they not only have structural hazards and Class B fuel hazards, but now lithium-ion battery hazards are a big concern for airports, because there's a large conglomeration of EVs in their parking structures, ground support equipment that's switching over to lithium-ion battery power, soon to be aircraft as well. So they know what's coming. So listing of some fire departments that are already using it, some notable fire departments there, but every fire department from the largest to the smallest is important to us. We are truly concerned with the safety and effectiveness of people, whether they live in the middle of the Mississippi Delta somewhere or in the middle of Chicago. We want to make a difference and an impact on firefighters' lives and people's lives. Again, the conclusion: save lives and make firefighters more safe and effective. You have to follow this daily mantra in your operations, and that is, as water flows, so does F500. And with that, we're ready to take some questions. So I'm going to open up the chat here. If you haven't already typed your questions into the chat, go ahead and type them in. All right, I'm going to go to the top of the list here and look through here. Mike Greiner, our president, says happy birthday to Heather. Happy birthday, Heather.
Thank you.
Let's look here. Look for some questions. Okay. Question one, can we use it in extractors? Yes, you can use it in your PPE extractors. You can also use it as a primary decon agent on scene. So as part of NFPA 1851 with the post-fire on-scene decontamination that is mandated by NFPA for firefighter health and safety, you can use it on scene. So whether you put it in a tiny $20 pump-up sprayer from the big box store, or you put it in something like a TFT Pro Pack or our TKO nozzle, and firefighters come out and they're all full of gobbledygook from head to toe. Quick spray with F500, quick rinse, and you've got most of that contamination gone, encapsulated. It absorbs into those solids that have collected on the gear, encapsulated, soaked in. That quick rinse gets rid of most of it on scene. Then when you go to, if you're a department that does the turnout gear bagging, like is recommended in some cases as part of a post-fire decontamination protocol, you're stepping into that bag, you're taking off your gear, you're not re-aerosolizing dry products. It's largely been mitigated, taken down, kind of the old wet strip flush cover decontamination protocol. So as you're taking off the gear, you're not getting dangerous products back on your skin. You're bagging it up. It's in that big bag. You take it back to the fire station. What happens if it's dry and not treated with anything? You open up the bag. You get a nose full of those polycyclic aromatic hydrocarbons, and then you pull it out of the bag. You start disassembling it. It gets all over your arms and wrists before you shove it in the extractor. guess what? You just got a secondary exposure. Or if someone's doing it that wasn't at the fire, they just got a secondary exposure and you carried it into your fire station. Same with fire hose and equipment. You can clean it off at the scene with a little splash of F500, a quick rinse, you've gotten rid of most of it. Then you can come back with confidence and a little bit of care, maybe some medical gloves or whatever, safety glasses, take it apart more carefully, get it in the extractor. Just 3 or 4 ounces of F500 can replace your normal laundering compound. And you're coming out of the extractor with gear that's not only much cleaner, that whether you got a spill on it or from oil from your last crash or byproducts of combustion from your house fire, you can wear that gear with confidence, knowing that there's no more PAHs coming off of that gear to harm you. But be careful. A lot of firefighters, they miss the most important parts. How about that liner in your helmet that you've been wearing for 10 years without washing it? How about your gloves? Those kind of things, the hood, the inside of your boots. Get those areas that you don't normally get and get them every time. Wash off the surface of that helmet that you're really proud of that used to be light color that's now a dark color with an encapsulator agent and scrub it well. And it'll come out smelling like a new car. And that gives you a lot of confidence right there that I'm no longer smelling that smoke that is somewhat of a badge of honor, but it's really killing me. So we'll move on to the next question. There's kind of a secondary question in this one, and it's about cancer and lawsuits and firefighting agents. Those are firefighting agents with PFAS. So PFAS are perfluoroalkylated substances that are put purposefully into firefighting foam, and they were put in there purposefully into legacy AFFF foam and AR-AFFF foam at a higher rate because they worked well. They worked really well at creating a surface film over that flammable liquid, keeping the vapors down. Keeping the vapors down equates to no fire. It also separates that liquid from our water-laden bubble structure. If you've got a water immiscible flammable liquid under there, like an alcohol-based product or an acetone, it would suck the water out of the bubbles and destroy the blanket. That PFAS worked great at creating a layer of separation. We can't use PFAS anymore. Nobody can. But if you think about the purpose behind PFAS, it was to separate or cause separation. We don't want F500 to be separate. We want F500 to mix with the fuel and or soak into fuel. PFAS would be counter productive to the performance of F500, so it's never been a part of it, never been added, and it's PFAS free, and we've got 25 years of lab records to prove it. So there's no record reportable chemicals in F500, and it's biodegradable. All right, freeze thaw. F500 concentrate in the bucket. If it freezes, and it will, it'll turn into a giant ice cube, but then when you thaw it out, it'll be okay. And it'll still be itself. It won't separate, and you can still use it. Now, in a water tank, it's going to freeze at 32 degrees Fahrenheit or 0 degrees Celsius and turn into ice just like water would. So take that for what it's worth. But I've never seen a fire department not put water on the fire because they're afraid of it freezing. So whether you're in Calgary or in South America somewhere, if you're going to use water to fight fire, you can use F500. Safe to use on bodies of water. Yes, you can use it on boat and marina fires to put the fire out. To mitigate spills, however, you need to check with your environmental authority, whoever that is, before you apply it to water. We've applied it with permission worldwide on spills as a spill dispersant, but with their permission. And it is a point source, as is documented in our chemical characteristics documentation, SDSs, etc., is a point source for uh, marine effects because it coats the gills of fish, but any surfactant does, whether it's a farm chemical or any kind of surfactant for anything, it will do the same thing. The nice thing about F500 in that environment is it's got that high molecular weight. It's going to settle to the bottom, be absorbed into the base materials of the lake or the body of water, and be mitigated by the microbes in the water. They're going to eat it up, and it self-dilutes, so it rushes apart because of the amphipathic molecule. So it's not going to sit concentrated in any one area and cause any problem. It's going to be a point source for a little bit of time, and then it's going to go away. But for boat and marina fires, very applicable. Stop applying it when the fire goes out. How will you apply F500 in an open cast lithium mine, both for reducing groundwater pollution by heavy metals from the extraction process and for stopping a massive lithium fire in case the raw lithium catches on fire? Well, to answer that simply, although it's a complicated question, but it's a pretty simple answer. The same way you would apply water. You're just going to have F500 in it, and it's going to go out faster. And it's going to take less water, so you're going to have less runoff. So at any kind of mining operation, there are some fire hazards and some atmospheric hazard. We've never found any contraindication to use of our product in any fire situation. So I'm sure it would be helpful in this one as well, although we have to look at and we do consult on with specific industries on the best way to apply it so that it's more optimal. Number one, to keep personnel out of harm's way, and then number two, to have the greatest effect on life safety. So we'll look at things like that as we help you apply. So fill out our contact card online with somebody in touch with you that speaks your language, number one, knows your industry, and can help you work through the processes of dealing with the application equipment that you already have. And if you need new application equipment to better apply F500, then we can help you with that as well. All right. I'm seeing a lot of others. I'm opening the other, besides chat, there's a Q&A. I'm opening that up. Okay. Do you have nozzles larger than 500 liters, or in other words, about 125? Nozzles larger than 500 liters. I'm not sure if I know what you're asking there for sure, but you can apply it with any size nozzle. We do have some nozzles like our TKO nozzles, only 70 liters per minute, 75 liters per minute, excuse me, 20 gallons per minute. But we also, no matter what your fire service distributor sells, you can put F500 through it. And we also are a TFT dealer ourselves. If you need a specific nozzle for a specific concern or a specific application, we can help you with that. We work in the fire service typically through our municipal fire service distributors here in the US, but in some other worldwide locations, that arrangement might be somewhat different. What you have to do is call us up, get a hold of us. We'll help you with whatever your application related concern is to meet your needs to get water to the fire. What would you say some of the negatives are of the F500 product? Well, that's a very good question. So I think freezing surfaces in the winter are potentially a negative. So if you wouldn't flush it off with water when it's, here in Nebraska, it gets pretty darn cold. And there are days when the surface of the pavement on the street is probably approaching 0 degrees. So application for a fuel spill or something like that, in that case, might not be your best option unless you can apply enough to warm the pavement, encapsulate, and then apply a dry absorbent after that. But that might take more than you want to put down. So in that case, you might go to a dry absorbent instead, or opt for a dry absorbent instead. So there are some things like that, but no matter where you're applying it to a combustible metals fire, you've seen the fire on YouTube in the last, I don't know, 6 to 8 months going around where the firefighter approaching the back of a semi trailer, the doors are open. He hits it with plain water and he gets a big fireball coming out because there's combustible metals involved. At 3% with F500, you won't have that. You'll just have a fire that goes out and with no negative reaction. So there are a lot of benefits. I could sure, I've been doing firefighting and I've seen fires in, I don't know, I can't imagine environments that I haven't seen it in, but then every day I see something new on YouTube and I'm like, wow, who would have thought that would have happened? But there are tactical and tactically important application variations to all different fire classes, but especially different fire situations. For example, a couple of weeks ago in North Dakota, they had a rail car incident, a derailment where there were ethanol cars and cars filled with plastic beads for injection molding, all in the same pile, all on fire. How do you approach it? From a distance with F500 and don't get too close because you don't really know what's going to happen inside of those pressure containers and when they're going to let go. So it's not something that's going to save the world from the throes of fire, but if you apply it from a tactically reasonable perspective, it's going to shorten your time on scene and shorten your exposure and your risk and really help the victims. So what's the shelf life of the product? That's the last question I see, and that is 15-year shelf life in the container. We could go longer than that, but we've tested it out to 15 years. And if it's sitting on the shelf for 15 years, number one, it's time to train with it. So use it up. Number two, you're not using it to save lives because you left it on the shelf for 15 years. So we really want you to use it to save lives because we think it's going to make a huge impact. And we think it's going to make a huge impact on your firefighters' lives as well because it's going to lower their career carcinogen exposure. And that's a big deal. I'm going to flash back over here to the other side. Okay, fog. Hang on, let me make sure I got all these. Thanks for my question. Looks positive. Somebody put in for a grant. That's good. We like to see grants. Make sure in your grant you're asking for training as well. We can come do some training with you. Ask us what that training might cost, and we'll train you to be to the specialist level in application, and then you can carry on your own training from that point forward. Fog versus smoothbore. You want to start an argument? No. So we recommend a fog nozzle because it's always already coming out as smaller droplets. It's already mixing better with the water because of the small openings of the fog nozzle. And then as it's applied, it's absorbing heat more uniformly. And it's also encapsulating those byproducts of combustion more uniformly and more rapidly from a fog nozzle. So I can prove to you all day long, I can throw a straight stream from a fog nozzle as far as you can from a smoothbore. The nice thing with the high molecular weight, it's a better straight stream. And when it comes to structural applications in an interior environment, smoothbores have their pluses. They really do. When it comes to that transitional attack and the bigger droplets and all that kind of stuff. But when you put F500 in a fog stream, you're going to get superior performance compared to a smoothbore with plain water every day. And when you put F500 in a smoothbore, you're going to get enhanced performance from that too, just not the best enhanced performance you could have got with that fog nozzle. And the thing that I look at, it depends on your environment. Most of us aren't fighting tenement house fires all day and apartment fires. Most of us would be just as likely to go to a vehicle fire, a school bus fire, a tractor fire, a propane tank on fire, and a house fire in the same day. So having that fog nozzle is is a benefit to you from all of the firefighting aspects for everything but structural. So whereas smoothbore is mostly applicable to structural fires, that fog nozzle can do them all. So I like it as a tool. I wouldn't say rule out smoothbore. I really like, for example, and every manufacturer makes one of these, the Elkhart Chief XD series of nozzles with the break apart nozzle. You've got a smoothbore with the shut off, and then you've got the screw off break apart nozzle tip with the fog nozzle. You can lead off with the fog nozzle attached, and if you get to a point where I want to switch to smoothbore, just knock off the head and throw it in your thigh pocket and keep working. So that doesn't answer your question. Re-ask or ask in a different way, but we're definitely open to working with anybody on that kind of stuff. Hope I got everybody's questions here. I like seeing people here looking for solutions to different problems. Lithium-ion batteries and EVs as a big problem going around, and we feel that number one, we're the longest standing solution out there, the one that's got many more years of testing behind it, and we can help you with modern vehicle fires in general, whether it's combustible metals, EVs, hybrids that are now using lithium-ion batteries and going away from nickel metal hydride. You've got to apply different tactics to all vehicle fires from this point on, not just EV fires. So in plain water is not applicable to most. Heather, do you see any questions that I've missed?
I don't believe so. If you want to just take a quick look in the Q&A box and let me know if you did answer those 2 questions live.
Can you repeat that one more time? You're kind of faint.
Sure. Just if you don't mind opening up that Q&A box and letting me know if those 2 outstanding questions were fully answered live.
Does it lower free? Okay. Do you have larger? I don't know if I've answered that one other than yes. Does it lower freeze point? No, it freezes right around 32 degrees Fahrenheit or 0 degrees Celsius. So it really doesn't change the freeze point of your already existing water. But we have bigger nozzles available. Your fire service distributor has bigger nozzles available, and you can use as big of a nozzle as you can imagine, or the smallest one if that's what applies to you. High pressure systems. If you've got brush trucks with high pressure pumps, use it. You'll see an amazing difference in the effectiveness of that fire stream on application to brush fires and things of that nature. So you can use it through any water delivery system. All right, let's see. So if you would like to get a hold of us at any time, you can go email us at info@hct-world.com. We have contact forms on our website as well. You can call us at the number there. That's our US number. Those of you from different continents and countries, look us up on the web. We've got a distributor available to you. So reach out to us with any more questions. Every state here in the US has what we call a manufacturer sales representative or encapsulator specialist like myself that can answer your questions, help with training needs. But we also have our municipal fire service distributors that are really, if you know who that is, then work through them to get F500, and they'll call us eventually with any other outstanding training needs or anything like that. But we work through that distributor network for the municipal fire service. So, and through them, you're getting the best price available. So, if you have any questions, be sure to contact us, and I hope you all have a great week.